This is Further Maths WAEC revision class, and I will be solving the questions just the way you would solve them if you encounter these questions in the forthcoming WAEC. So the first question here says, find the equation of the tangent to the curve y is equals to x minus 1. So I am going to write the question first, x minus 1 over 2x plus 1. So the first thing, and they said x is not equal to negative 1 over 2 at the point 1, 0. So now that we have been given this is division. So we are going to apply the quotient rule to do this. Usually, in quotient rule, you call the numerator u and the denominator is referred to as v. So you differentiate both u and v with respect to x. So if I do du over dx, this will give me, if I differentiate this, x, right? Remember, to do the differentiation of x to the power of n, quickly, you take your n, the power, multiply what you have here. So this, the y dx here will just give you n times everything you have here, x to the power of n, then you subtract 1 from the power. That is how to do differentiation. So if you have a coefficient, let's assume you have ax to the power of n. What you do is you take the n, you multiply what you have here. So this becomes n times ax to the power of n minus 1. Good. So we'll apply that here. So this would now look like this. Since this is 1x, because when you have a variable like that, the coefficient is automatically 1, and the power also is 1. So you do 1 times 1x to the power of 1 minus 1. And we know that 1 minus 1 will give us 0. So, and anything to the power of 0 is 1. So 1 times 1 times 1 is 1. So it means if you differentiate this x, you get 1. Now, if you differentiate the v with respect to x as well, right? Since this is 2x to the power of 1, if you differentiate it using the same method, you do 1 multiplied by 2. Then remember 1 minus 1. So 1 minus 1 is 0. Anything to the power of 0 gives us 1. So this also becomes 2. Good. So I've differentiated both u and v. So I am going to apply a very straightforward formula. And the formula to differentiate dy dx for divisions like this, we call it quotient rule. So dy dx will now become v du dx minus u dv dx over v squared. Now, this is where it gets very interesting. Now, our v is 2x plus 1. So I'm going to write that here. So this is 2x plus 1. Then du dx is 1. Are you following? Good. Then minus. Our u is x minus 1. So this is x minus 1. Then our dv dx is 2. So permit me to put the 2 in front. So divided by v squared. Our v is 2x plus 1. So 2x plus 1 squared. Good. So if you expand the numerator, this will give you 2x plus 1, because 1 times that will give us everything in the bracket. So negative 2x plus 2. So negative 2x, then plus 1, plus 2. Minus times minus is plus. Then 2 times 1 is 2 over everything at the denominator is still the same. So here, 2x, we cancel 2x. So, right? So if 2x cancel 2x, I'm left with 1 plus 2. And 1 plus 2 is what? Is 3 over 2x plus 1 squared. So now, looking at this, that is our differentiation of the y dx. So we are going to put the point 1, 0, right? So let's go. So now at 1, 0, what would the y dx be? The y dx will now be 3 over. Now, whenever you see coordinates like this, the first represents x, the second represents y. So this becomes 2 times our x is 1 plus 1, all carrying a power of 2. So this is still 3 over 2 times 1 is 2, then plus 1. Remember, it's squared. So this is 3 over 2 plus 1 is 3, and 3 squared is 9. So 3 can go in 9 3 times. So this is 1 over 3. So it means that our dy dx is 1 over 3. Dy dx is the slope of the curve. And mind you, the slope of the curve is still the slope of the line. So we will now use the equation of the tangent, right, to continue solving. Now remember, once you are given just one set of coordinates, right, equation of the tangent is y minus y1 equals to m x minus x1. So you are going to take your x1 to be 1 and your y1 to be 0. So substituting it into this formula, it will become y minus our y1 is 0, then m, our x is 1. Sorry, our x, you write x, then minus our x1 is 1. So this y minus 0 is still y equals to, good, our gradient, we have obtained the gradient. We said that the gradient of the curve is the same as the gradient of the line. So our m is 1 over 3. So this becomes 1 over 3, then x minus 1. So if you cross multiply, this becomes 3y equals to x minus 1. So you can put everything together as 3y minus x plus 1 equals to 0. So this becomes the equation of the tangent of the curve to the curve. Is that taken? All right, so that is the first question. So now let's look at the second question. Interesting one here. The second question says that 3x squared plus 2y squared plus xy plus x minus 7 equals 0. Now we have to find the y dx at the point minus 2 and 1. So now let's look at the second question. I hope you understand what we are doing. If you understand, please just type in the comment section, I understand. Like I said earlier, I said I'm going to drop the solution sheet, right, in the WhatsApp group. For those of you that are in the WhatsApp group, I'm going to drop the solution for every question that we'll be looking at. so that if there's anything you missed out during the course of my explanation, you will see it in the solution sheet. So now, let's look at the next question. This next question here is interesting. And the reason why it's interesting is because this is what we call implicit differentiation. You know, normally differentiation will come in form of y equals to something 2x squared plus 5x minus 4, right? Where you have y in one place and x in another place, x and y in different positions. But in this case, you can see x and y mixed together. So to differentiate this, watch what I'm going to do, right? You differentiate 3x squared normally, right? Remember, I've showed you how to differentiate in the previous question using this model, y equals to ax to the power of n, where you say the y, the x will be, you take the power, multiply everything. So this becomes x n times ax, then you take away 1 from the power. Good. We are going to use that model now to differentiate them term by term. So I want to differentiate the first term here, which is 3x squared. So I'm going to take 2 times 3. So this is what I will do. I will say d dx of everything I have here plus 2y squared plus xy plus x minus 7 equals to d dx of 0 as well, right? So doing this means 2 times 3, that will become 6x. Then take away 1 from 2, that becomes 1. So there's no need to write that 1. Now, this is y, right? Normally, it is dy dx. So as long as you are differentiating y with respect to x, you are going to say 2 times 2 usual, that will be 4. Then y, 2 minus 1 is 1, right? Because you differentiated the term involving y, you put the y dx beside it. Good. Then this xy, you are going to treat it as a product of x multiplied by y. So the model is simple. The model is simple. You differentiate x first, you leave y. Then you say plus. In the first one, we differentiated x, we left y. In the next one, I'm going to differentiate y and leave x. So let's implement what I've just said. So now I want to differentiate x. If you differentiate just x to the power of 1, that will be 1 times x, which is 1x to the power of 1 minus 1. 1 minus 1 is 0. Anything to the power of 0 is 1. So 1 times 1 is 1. So there's no need writing that 1 there. So if I differentiate x, I will get 1. So remember I said I will differentiate x and leave y. So I'm going to leave y now. Good, then plus. Now I want to differentiate y and leave x. Now y will look is the same thing as x. So if you differentiate y, you are going to get 1, right? But remember I said I will leave x. Now because we differentiated y, I am going to put, right, x here, then multiply by dy dx. Because I differentiated y, that is why I'm leaving dy dx here. Then plus, if you differentiate x, you will get 1. Now, if you differentiate a constant, you will get 0. 7, for instance, is a constant. So let me prove that to you. The variable here is x to the power of 0. So it means that if you do 0 times everything here, so 0 times 7x to the power of 0 minus 1. 0 multiplied by everything, I've rendered it to be 0. So this is minus 0. Similarly, if I differentiate this 0 here, I'll still get 0. So this is what I'm going to do. I'm going to all the terms that have the y, the x, I'm going to put them together. They are 4y plus x. So I will put the y, the x beside it. So I'm going to transfer every other thing without the y, the x to the right-hand side. So this becomes negative 6x. Remember, when in mathematics, when any number or variable cross the equal to sign, the sign will change. So this will become minus y, then minus 1, right? Good. Let me leave the over first. So therefore, if I make the y dx to stand alone, that will become negative 6x. I can put it in bracket like that and say plus y plus 1, because minus will affect everything. Then divided by 4y plus x. Now, they said we should find it at the point minus 2, comma 1. So it then means that at minus 2, comma 1, this is our x, this is our y. So therefore, anywhere I see x, here I will put minus 2. Anywhere I see y, I will put 1, then plus 1 over 4y, that's 4 times 1, plus minus 2. So now this is still minus 6 times negative 2 is negative 12. 1 plus 1 is 2 over 4 times 1 is 4. Plus times minus is minus, that's minus 2. So minus, I have minus 12 plus 2 is negative 10 over 4 minus 2 is 2. Minus times minus is plus, so this becomes 10 divided by 2. Therefore, I will say the y dx at minus 2, comma 1 is equals to 2 goes in 10, 5. So we will obtain 5 in this particular one. Now let's cross-check what we have done. This is 6 times x, 6 times minus 2, then plus y. Our y is 1, and we have 1 there. Then 4y, 4 times 1. Then plus x, that's minus 2, right? So, right, 6 times, oh, sorry, the minus here is going to affect this and this. So this will not be plus and plus. So this will be minus 1, minus 1. Sorry about that. So this will be minus, minus. Remember, there's a minus here. So the minus will affect everything. So let me interpret it correctly. Or for the sake of those of you that may not understand what I have done, I'm going to write it the way it is in the rough form so that you will see what I am saying. Good. Sorry about that. That's why you need to cross-check your work every time you solve. You check what you've done so that you can be sure of your results. All right, so let's go. So I'm going to write minus 6x minus y minus 1. So let's substitute now. Minus 6 times x is minus 2. Then minus y means our y is 1. Then minus 1. Minus times minus is plus. 6 times 2 is 12. Then minus 2. So 12 minus 2 is 10, right? Okay. So 12 minus 2 is 10. 10 over 2 is 5. Okay, we are still correct. That's 5, right? So that is it. Okay. Then let's move on to the next question. The question here is, if y is 2x plus 3 to the power of 7 plus this, find the y dx at x equals minus 1. It's similar to what we've just done. So I'm going to write solution. So now for this, I'm going to write out my question. So this is 2x plus 3 to the power of 7 plus x minus 1 over 2x minus 1. So the first thing I would do is I am going to differentiate each of these terms. So dy dx means if I differentiate this, if I do d dx of 2x plus 3 to the power of 7, then plus, if I do d dx again, of x minus 1 over 2x minus 1. Good. So let's continue. So this is what we call function of a function, assuming y is 2x plus 3 to the power of 7. First of all, you would call what is in the brackets u, for instance. So you say u is now 2x plus 3. Therefore, we can say y is now u to the power of 7. So we differentiate the u with respect to x. We will get 2, yeah? Then if you differentiate the y with respect to u, you will get 7u to the power of 6. So therefore, the y dx here will now become the y du times the u dx. So if the u cancels the u, you have the y dx equals the y dx. So the y du is 7u to the power of 6 times the u dx, which is 2, right? So now I will leave it like this, and I will show you a very fast way to differentiate questions like this. So this is it. You take the 7 here, you multiply everything you have in the bracket, then you take away 1 from the power. This is the power of 6. We are done differentiating. Now, let's come back to this. Then you differentiate what you have inside the bracket. 2x plus 3, if you differentiate it, you will get times 2. Right? Then, now, remember we said that u is 2x plus 3. So if you put this back into the bracket, 2x plus 3 to the power of 6 times 2, you can see the same result. Good. So, but 2 times 7 is 14. So let me just put 14 here. Good. Then if you use the quotient rule here, which is v, our v is 2x minus 1. 2x minus 1. Then du is x minus 1. So if you differentiate x minus 1, you will get 1. Minus u is x minus 1. Then dv, if I differentiate what's the denominator, I'll get 2. Then yeah, everything over v squared, which is 2x minus 1. Then you square it. Good. So remember, everything we are doing is dy dx. So this is now 14 to the power of 2x plus 3 to the power of 6. So expand the bracket here. This is 2x minus 1, then minus 2x plus 2. Everything over 2x minus 1 all squared. So therefore, if you treat this very well, it's going to give us something like, okay, let me continue here. The y dx. So I'll write down 14, open bracket, 2x plus 3 to the power of 6 plus. So 2x minus 2x will cancel out. Then minus 1 plus 2, that is 1 over everything we have here is 2x minus 1 squared. Good. So we were told to find the y dx at x equals to minus 1. So everywhere we see x, I'm going to put minus 1 there. So 2 times minus 1 plus 3. Everything is carrying a power of 6 plus 1 over 2 times minus 1 minus 1 again. Everything carrying a power of 2. So 14, this is minus 2 plus 3 to the power of 6, 1 over. Now, yeah, 2 times minus 1 is minus 2, and minus 1 squared. So this is 14. This is as good as saying 3 minus 2, which is 1 to the power of 6. Minus 2 minus 1 is minus 3 to the power of 2. 1 to the power of 6 is still 1, so this is 14 plus, if you square minus 3, you get 9. So the y dx is 14 no number 1 over 9. That's our dy dx at x to be negative 1. Are you following? I hope you are following. All right. So let's look at the next question. Now, the next question is straight to the point. We're given that the gradient of the function y is equals to ax squared plus bx plus c is 8x plus 4. What does this imply? It means that if I differentiate this, I'm going to get 8x plus 4, right? That is assuming I know what A is, B is, and C. That if I differentiate it, I'm going to get something of this nature. Now, if the function has a minimum value of 1, we have to find the value of A, B, and C. So the first thing to do here is to differentiate y with respect to x. So as usual, 2 will multiply everything here. Then take away 1 from the power, you have 2ax. Now, b is a constant. So if I differentiate bx, I'll get just b. Then c is a constant. If I differentiate it, I'll get 0. Now, because we were told that since dy dx is 8x plus 4, therefore we can say 2ax plus b is 8x plus 4. Then, by comparing, it means that my 2ax is the same thing as 8x. X will cancel x. So therefore, here, A will become 8 divided by 2, which is 4. Good. Then, automatically, our B, which is the constant, is also equals to 4. You can see it, right? Good. So now, we are left with obtaining C. So how do we get the value for C? Now, the minimum of any quadratic equation, right? Are you with me? The minimum occurs where x is negative b over 2a. Now we know what b and a is, so therefore x is now negative 4 over 2a, 2 times 4. So this is 4, negative 4 over 8, which is negative 1 over 2. So that's the value for x. So I'm going to substitute the value for x back into the original equation alongside a and b, right? To now get something that looks like this. Y equals to a is 4, x is negative half, then it is squared, plus b is 4, then x is negative half, plus c, right? Are you following me? Are you? Good. Then there's something I will do. You know, they said at minimum, if the function has a minimum value of 1, so it means that our y here will take up the value of 1, because at minimum, remember, the minimum occur at x equals to minus b over 2a, and that gave us negative half. So that's why we are equating to 1 here. So 1 is equals to 4. This is 1 over 4, because negative squared is positive, right? Then 2 squared is 4. Then this positive times negative here is negative. 2 can go in 4 2 times, so this is minus 2 plus c. So 4 we cancel 4 here, that's 1. So this is 1 is equals to 1 minus 2 plus c. So by the time we make c the subject, it will now become, if every other thing go to the other side, 2 go here will be positive, minus 1, then plus 1. This 2 will cancel, so c becomes 2. So therefore, it means that our A is 4, our B is 4, and our C is 2. All right. So you will write that down. So let's move on. Okay. So let's look at the next question, number 5. Mind you, all of the questions we have been looking at are majorly application to differentiation, right? Major applications, right? So, and the question we're about to look at now is still an application question in differentiation. So, and this is a very interesting one because it's word problem. So we'll interpret. Good. So let's go. We're told that the volume of a cube is increasing at a rate. When you say rate, rate means over time. And you can see the unit, volume over time, right? So volume over time. Time is in seconds, volume is centimeter cube. So based on that, I'm going to generate a formula, and we know that the volume of a cube is the cube of the sides. So if the side is S, right? to be s cubed, right? Where our s is the side of the cube. Is the side of the cube. So if I differentiate the volume with respect to the side, dv ds, this becomes 3x, so 3 minus 1, this is 2. So I'll get 3x squared. Are you following me? So, but I need to get volume with respect to time, because they said the volume of it increased by this rate. So I will generate a formula by saying that dv dt will now be dv ds times ds dt. So that ds will cancel ds, then you have dv over dt equals to dv over dt. Good. They now say find the rate of change of the side of the base, which is length, when its length is 2 centimeters, and that length is the same as the side of the cube. Are you following? Good. So here, our S is 2 centimeters. The VDS is 3x squared. Then the S dt, right, is this 5 over 2. 5 upon 2. So this becomes 3 times the side here is 2 squared times 5 upon 2. So this is 3 times, this is 12 here times 5 over 2. 2 here 1, 2 here 6. 6 times 5 is 30. And that is our dv dt. That is the question. That's the solution. The rate of change of the side of its base when its length is 2 centimeters. So, all right. Now, this is an activity for you to attempt. Now, for the sake of time, I will not be doing this in the live class, but remember that you use your quotient rule. You make your u to be x plus 1 and your v to be x plus 1 squared. So if you differentiate u with respect to x, you'll get 1. And if you differentiate dv with respect to x, remember the protocol. You take the 2, multiply everything in the bracket, take 1 from the power, then multiply what you have inside the bracket, that's 1. So it will still end up becoming 2x plus 2. So if you now do dy dx, using v du dx minus u dv dx over v squared, it will now amount to v is x plus 1 squared, then du dx is 1, minus u is x plus 1, then dv dx is 2x plus 2. Everything over v squared. V squared is x plus 1 squared, then squared. Are you following? Good. So it then means that dy dx, if I square x plus 1, I will get x squared plus, now to multiply something like this, x plus 1, just square the first one, take 1, multiply x, you will get x. Then multiply it by 2, you will get 2x. Then square the last, this 1. 1 squared is 1. That's what you will get here. you get x squared plus 2x plus 1. Then, if I expand this, remember, the negative will affect everything here. So this becomes 2x squared plus 2x plus 2x. That's 4x plus 2. I hope I'm correct. I hope I am correct. Okay, so over v squared, this become x plus 1. Squared will turn to 4. 2 times 2. Good. So have I expanded this very well? Our u is x plus 1. Our v is x plus 1 squared. Du dx is 1. dv dx is 2x plus 1. So using the formula v du dx minus 2 into x plus 1, then another x plus 1. dv dx, u dv dx. Okay. Okay, let's see what this will give us. If I maintain this one here, I want to make it easy so that I won't get all this complex numerator. Remember, this is 2 into x plus 1. Let's maintain it that way for ease of calculation. So our u is x plus 1, then dv dx is 2 into x plus 1 again. So this is x plus 1. Let me put that 2 here. So this, if you multiply this, this will become x plus 1 squared minus 2. X plus 1 is another x plus 1 squared. Good. So you have x plus 1 squared minus 2 into another x plus 1. This will become negative x plus 1 over x plus 1 to the power of 4. Right? So you can see we have made it very simple, right? So this is power of 1 such that this can cancel and we have just 3 left here. 1 over x plus 1 cube. Good. This is way simpler than expanding all of that. We'll still arrive at the same answer, but this is in a more simplified manner. Is that clear? So let's move on to the second question. Now, a side of a rectangle is 3 times the other if the perimeter increase by 2%. Okay. Find the percentage increase in the area of the rectangle. Interesting question. A side of a rectangle is 3 times the other. So I believe the width, let the width be x, Then the length is 3 times the other. Let it be 3x. Good. We know that perimeter of a rectangle, perimeter P is 2 into length plus width. So length is x, sorry, 3x, width is x. So this is 3x plus x, that's 4x. 2 times 4x is 8x. Good. So now this is P, that is 8x. Now I want to differentiate P with respect to x. So if I do dP dx, I will get just 8 because the power here is 1. 1 times 8 is 8. Then you write the x to the power of 1. Take away 1 from the power. 1 minus 1 is 0. Anything to the power of 0 is 1. So 1 times 8 is 8. 8 times 1 is still 8. So dP dx is 8. Good. So we want to increase, the increase in P is dP over P. And what is dP? Right? What's our dP? Our change in P, what's it? If I make dP the subject of the formula here, I will have 8 multiplied by dx. That's not so. So it means that our dP is 8 dx. Then what's our P? Our P is 8x. So here 8 will cancel 8. So therefore, our increase in P is dx over x. Now, since dP over P, that means the increase in the perimeter is dx over x. And we're given that if the perimeter increased by 2%, find the percentage increase in the area. So now let us now look at the area of rectangle. Area of a rectangle A is length times width. Our length here is 3x, our width is x. So this is 3x squared. So the same way I treated this, I will treat this as well. So I will differentiate A with respect to x. This will become 2 times 3, 6x. Take away 1 from the power, that becomes 1. So dA dx is 6x. So it then means that our dA will now be 6x dx. So the increase in area, means I will do dA over A. And our dA is 6x dx. And our area is 3x squared. 3x squared. 3 can go in 6 2 times. X cancels 1x. So we have 2 dx over x. So the increase in area, now since the increase in area is 2 dx over x, right? And we were told that it increased by 2%. So therefore, it then means that dx over x, that is the increase of 2%. Find the percentage increase in the area, right? So what do we do to this, right? So this becomes 2 multiplied by that 2%, right? So that becomes 4%. Is that clear? All right. So let's move on. Now let's move on to integration. I was not supposed to treat that activity, but I just have to treat it for sake of those of us that may not understand. Okay. Now, we were asked to use U substitution to evaluate this. So this is the integral of 2, 1, then x over square root of 5 minus x squared, then dx. So now, we were told to say our u is 5 minus x squared. So I want to differentiate u now with respect to x. This will now be, if you differentiate a constant, you get 0. And minus x squared is negative 2x. So from this, I want to make the x to stand alone. So from this, the x standing alone will now be negative du over 2x. Is that clear? Now, is that taken? From this equation, I want to make some assumptions. Now, when x is 2, what would our u be? If you put x to be 2 here, so this becomes 5 minus 2 times 2 is 4. 5 minus 4 is 1. Right? So our u is 1. What if x is 1? Right? If our x is 1, what would our u be? Our u will be 5 minus 1 squared is 1. 5 minus 1 is 4. So I'm going to use this coordinate now to flip our integral. Therefore, the integral, instead of the bigger value being up now, I'm going to put 1 on top and 4. 1 will become my upper limit and 4 my lower limit. Is that clear? So now I will put my x here over. Now we have said that 5 minus this is u, so I'll leave it there. What's our dx? Our dx is du over negative 2x. Now, x will cancel x. Mind you, we don't integrate a constant, so I'll bring it out. So this becomes negative 1 over 2. My integral system, 1, 4. Then this is 1 over square root of u, then du. So now the journey to integration begins. Is that clear? So this is negative 1 over 2. Open a bracket like that. So 1 over this is the same thing as saying u to the power of minus 1. Are you with me? Then the limits now, 1 and 4 will be there. So now, square root can be written as u to the power of half, right? Then you have half, then times minus 1. Are you with me? So if you multiply by minus 1, you will now get u to the power of negative half. Are you following me? Or let's take that part again. Now, -1/2. Now, our u, square root of u is -half, right? Now, based on integration, our u on its own is half, then times 1 times -1 makes it -half. Then the rule of integration says add 1 to the power, then the numerator, you use it to, sorry, the power, use it to divide. So our limit is still there, 1 and 4. So if you simplify this further, -half will now be 1 minus half is 1 minus half is half, then over 1 minus half here is still half. Our limit is still this. So therefore, if you divide this now, this will become negative this. U divided by half becomes 2u. Then to the power of half. Then our limit still stands. So by the time we now put in our values of our limits into it now, so this becomes 2 times upper limit, which is 1 to the power of half, minus 2, then u again here is 4 to the power of half. Yes, so this becomes minus half. Square root of 1 means this half, raised to power half means square root. So square root of 1 is 1. So you have 1 times 2 is 2, minus square root of 4 is 2. 2 times 2 is 4. So this becomes minus 1/2 times 2 times minus 4 is minus 2. Minus times minus is plus. So 2 we cancel 2, you get 1. So that is the value. Then, are you with me? Good. So let's move on. In number 2, we are to calculate the area of the finite region bounded by 2 curves. And these are the 2 curves, y equals to 6 minus x minus x squared, and the other one is y equals to 3x squared minus 2x plus 3. So the first thing we need to do is to find the point of intersection. That's the first step. Now, to find the point of intersection, since both of them are y, equate them together. Therefore, we can say that 6 minus x minus x squared will be equals to 3x squared minus 2x. Let me write 2 very well. Plus 3. Good. So I want to collect like terms. Or let me move everything to one side. So I'll move everything here to this portion. So this becomes 0. So 3x squared, if minus x squared crosses to this side, become positive x squared. And if you add 3x squared plus 1x squared, that will be 4x squared. Then this is negative 2. If negative 1x crosses, it becomes positive 1x. So negative 2 plus 1 is negative 2x. So this is positive 3. If positive 6 crosses, so this will become 3 minus 6, which is minus 3. Good. So that is the equation that we'll obtain, right, by the time we equate this. Sorry, by the time we equate both curves together. Now, I want to solve this quadratically. I want to find x. Now, negative 3 times 4 is negative 12. And here you have negative 2, negative 12, and negative 2. I need two numbers I will multiply that will give me negative 12. That when I add them up, I will get negative 2. What are those two numbers? Oh, sorry, there's an error here. If minus x crosses, it will become negative x, not 2x. Sorry. So it will be 4x squared minus x minus 3. Good. So this is not minus 2. This is one thing with maths. If you are wrong, you will know because you find out that some things will not add up. So already 4 times 3 will give us 12. So, and I need to get minus 1. So since I'm getting negative here, I will put the minus in the bigger number here. So minus 4 times 3 will give us minus 12. And minus 4 plus 3 will give us minus 1. So therefore, this becomes minus 4. Then this becomes plus 3. Now, because I have a coefficient with this x squared here, I'm going to divide both sides here by 4. By 4. Now, 4 here can divide 4. This is 1. So in the next bracket, this becomes x minus 1. Then the next bracket here, remember this is equal to 0. To remove this fraction, multiply both sides by 4. So the LCM is 4, multiply it by 4. This is 4x. Then 3 over 4 times 4, you will get 3. So using the zero product rule, means that x minus 1 is equal to 0, or 4x plus 3 equals to 0. So here, x is equals to 1, or x is equals to negative 3 over 4. Now, these values now will now form our limits. Is that clear? So we'll now form an integral where we'll put limits. Is that clear? So we want to determine the upper curve. Is that okay? So to determine the upper curve, so let me to determine the upper curve. So which of these two equations, we want to find out which of these two equations will be the upper curve. So to do that, I'm going to take x to be 0. Is that clear? So in the first one, y will now be 6 minus 0 minus 0 squared. I will get 6. Then in the other one, put x to be 0 again, 0 squared minus 2 times 0 plus 3. This will be 0, 0, then this will be 3. Of course, we know that 6 is bigger than 3. Therefore, what gave us 6? The equation that gave us 6 is the upper one, which is this one, right? That's the upper curve. So we are going to form an integral now that we know all of that. So we want to form an integral. Forming integral. So the area between the curve A will now be the integral. So this is where your limit now comes in. Upper limit is 1. That x will be 1. Then minus 3/4. Then our upper curve, which is 6 minus x squared. Then minus the lower curve, which is 3x squared minus 2x plus 3. Then anytime you put an integral, always wrap it up with the x. Are you following? So we still have work to do. Okay. So now let's go. Remember, the lower limit is negative 3/4. So I'm going to do my area now will now be, okay, I think I'll do it like because I need a lot of space. So to continue the solution, will this space be enough for what I want to do? Will it be enough? Let's look at it. Okay, you know what we'll do? It will be enough. Let's simplify this first. 1 and negative 3/4. Let's simplify. We'll simplify in this order. Now, we have 6 minus 3. That's positive 3. The minus x minus 2x, that will be plus 2x minus x, which is plus x. Then minus x squared minus 3x squared, that will be minus 4x squared. Then dx. Good. You can see that it has been simplified. So now we want to integrate. Now, mind you, integration is the reverse of differentiation. So to differentiate this now, 1 and negative 3/4, I am going to, okay, let's integrate this. So I'm going to put 3 plus, okay, let me integrate. Now to integrate, I am going to assume that there is an x to the power of 0 here. Now, I will add 1 to that power. 0 plus 1 is 1. So 0 plus 1 is 1. So this will give me 3x. So let me clean this off. Good. Then this, of course, is like saying x to the power of 1. So if I add 1 to that one, that will be 2. Then divide by that 2 minus. So I will add 1 to this 2. That will be 3. Then over 3. Then my limit still stands. 1 and minus 3/4. So now let's now solve this now. So this becomes 3. I'll put 1 here plus 1 squared over 2 minus 4 times 1 cubed over 3 minus now 3 times negative 3 over 4 plus x squared, that is negative 3 over 4 squared divided by 2 plus 4 negative 3 over 4 cubed over 3. So now let's simplify. 3 times 1, that is 3, plus 1 squared is 1 over 2. Then plus 1 cube is 1 times 4 is 4 upon 3. That's in the first bracket. Sorry, this is minus. So let's watch out for the signs, please. Very important. Then, yeah, 3 times 3 is 9. So this will be minus 9 over 4. Then if you square 3, that is 9. If you square 4, that's 16. Mind the negative squared is positive. If you divide by 2, right? So this will become times 1 over 2. So it will be 16 times 2, which will become 32. So just let me put 32 here. Are you following me? Then plus 4. If you cube negative 3 times, you will get negative 27. If you cube 4 3 times, you get 64. Everything here over 3. So what do we do? What do we do there to make that place easy? So let's go. If you add 3 plus half minus 4 over 3, the LCM here is 6. So if you multiply each by 6, 3 times 6 is, sorry, 6 times 3 is 18, right? So 6 here, this is 3 now, minus 3 times 2. 3 in 6 is 2. 2 times 4 is 8. Over 6. The minus. So if you simplify this 3 can divide 27 and it will go 9 times. So then simplifying all of this, we end up in, will give you 45, negative 45, mind you, to give you negative 45 over, I would encourage you to use your calculator, please. 45 over 32. So this portion, 8 plus 3 is 21 minus 8, that is 13 over 8 minus and minus return to plus 45 over 32. Now, to solve this, it can go in 32 4 times, right? So let me put 32 here. 8 in 32, that's 4. 4 times 13 is 56. Then 32 in 32, 1. 1 times 45 is 45. So 56 plus 45, what would that be? What's that? That will be 1. 6 plus 5 is 11. 5 plus 4 is 9. Plus 1, that's 10. 101 over 32. So that's it. So that is square units. So that is it. Oh, sorry about that. Our LCM here is 6. So how did it turn to 8? This is over 6. Okay, can't go in each other. So just do 13 times, 32 times. I want to use the butterfly method. 32 times 13 will give us uh, uh, 208. 6 times 45 will give us 135. Then 6 times 32 is 96. So if you add the numerators together, you get 343 over 96. Then square units. So that is it. So number 3 says we should use the trapezium rule. Using the trapezium rule with the ordinates at x equals to 1, 2, 3, and 4, 5, like that. What do we do? So write out the question. Then x plus 2 over x squared. Then dx. Now our ordinates are 1, 2, 3, 4, and 5. So I'm going to form a table for this. So the table will look like this. X, then one, 2, 3, 4, and 5. Then x squared, then 2, over x squared. Then y. And y is simply our equation, which is x plus 2 over x squared. So I'll square, everywhere I see x, I'll square it. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So 2 over x squared. Since our x squared is 1 here, 2 over 1 is 2. Then if you do 2 over 4, that's 0.5. Make it 3 GPs. Then 2 upon x squared is 2 over 9. So 2 over 9 is 0.2222. Then 2 upon 16 is 0.125. Then 2 upon x squared is 0.080. Okay, good. Then now we have to add the both together. X plus, we are adding just x now plus 2 over x squared. So the two results here is what we're adding. In x, then this. That's what we're adding. That is our y, right? So if you add 1 plus 2, that's 3. So this will be 2.500. This will be 3.222. This will be 4.125. This will be 5.080. Good. So the next step is applying the trapezium rule. And the trapezium rule says the lower limit is A, upper limit is B. Differential of y dx is approximately the width of the class over 2. Then our first value plus our last value plus 2 of the values in between, y1 plus y2 plus like that up to yn minus 1, right? Good. So using this model now, our class width is simple. It's just to say h, right? And h is simple. Just do 2 minus 1 or 3 minus 2 or 4 minus 3 or 5 minus 4, right? Which is the same as 3 minus 2. Any way you go, you get 1. So that is it. So this is approximately 1 over 2. Our first value here is 3. Our last value is 5.08. Then our values in between is from 2.5, 3.222, the 4.125. Oh, so sorry about that. Okay, 125. We'll work with that. This is half. So this is 8.08 plus 2. Let's add up everything in the brackets. You will get 9.845. 8.08. If you multiply this by 2, you will get 19.69. Then, of course, this is 0.5. If you add these two figures together, you'll get 27.77. By the time you multiply, you will get 13.885. Now, we were told to leave our answer to 2 decimal place. So this is 13.89 in 2 decimal place. That is it. All right. So here is an activity for you to try out. We have 2 questions here. All right, you can write out the question. Then second one as well. Now, the second one is a bit unique because we are going to use substitution there. Sorry, not use substitution as it were. So let me do this second one. Okay, we were told that u is x minus 2, and we're asked to write x cubed plus 5 over x minus 2 to the power 4 as an expression in terms of u. So since we want it in an expression as we want u to be in charge here, so I want to make x the subject of the formula. So if I make x the subject here, it will become u plus 2. Are you with me? So everywhere I see x, I'm going to put it as u plus 2. Then everywhere I see x minus 2, I'm going to put it as u. So therefore, x to the power of 3, x to the power of 3 over x minus 2 to the power of 4. So x is now u plus 2 cube, then plus 5. Then x minus 2, we have said this is u. So this is u to the power of 4. So now we want to expand this now. Now expanding u plus 2 to the power of 3 using the Pascal triangle, which is 1. Assume there's 0 here, 0. 0 plus 1 is 1. 1 plus 0 is 1. Put 0 here, put 0 here. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 0 is 1. Add 0, 0. 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. So this is sufficient for that expansion. Sufficient for it. So, and how will it work? As u will take the highest power of 3, the coefficient is 1. Then plus, since everything is positive. If it was negative, it will be positive, negative, positive, negative. It will be alternating. So here we have 3. Coefficient is 3 multiplied by 2. U will reduce by 1, so U will be squared. Then my 2 will increase by 1. So plus again, 3 again. U will reduce by 1. 2 will increase by 1. Then yeah, U would have finished reducing. So you have 1. U would have become 0. 2 will take the maximum power. Just as 2 here to the least power. If this is U to the power of 3, 2 here is taking the least power. So that's why I didn't bother to write it. 2 raised to the power 0 is still 1. So now let's simplify everything now. So this is U cubed. 2 times 3 is 6. U squared. 2 squared is 4. 4 times 3 is 12. U to the power of 1 plus U to the power of 0 is 1. Then 2 cubed is 8. So it means that U plus 2 cubed is the same thing as U to the power of 3 plus 6U squared plus 12U plus 8. Then you add the 5 to it. Everything over U to the power of 4. So if you simplify now, U to the power of 4 is dividing everything. So this becomes U to the power of 3 over U to the power of 4. 6U squared over U to the power of 4. U to the power of 4. 8 plus 5 is 13. So let me add them up. So this should be 13 over U to the power of 4. So it then means that if we simplify, the whole of this cancels 3 from this. You have 1 left. So this is 1 over U. 2 of this cancels 2 from this is squared. So this becomes 6 over U squared plus 1 will cancel 1 from this. You're left with U cubed is 12 over U cubed plus 13 over U to the power of 4. So that is the final result. Is that taken? All right. So let's move on. Let's look at the next question or the next topic, arithmetic and geometric progression. This is one topic you can't avoid. You meet it in both theory and in the objective paper. So let's interpret. The sum of the second and the fifth term of an arithmetic progression, AP, is 42. So let's go. Sum. So second and fifth term is 42. Now, if the difference between the sixth term and the third term, mind you, our C term or nth term of an AP is A plus N minus 1, where A is the first term, then N is the number of terms, then D is the common difference. Good. So, take notes. So, for the second term, if you put this to be 2, A is still A, second term means N is 2, 2 minus 1, then we don't know the common difference. So this becomes A. 2 minus 1 is 1. 1 times D is D. So the second term is A plus D. Then the fifth term means our N is 5. So 5 minus 1 gives us 4, right? 4D. Good. So our fifth term is A plus 4D, all equals to 42. So collect like term now. You have 2A plus 5D equals to 42. So call this equation 1 as a one-star general. So let's look at the next sentence. If the difference between the sixth and the third term is 12, difference means subtraction. Difference between the sixth term and the third term is 12. Let's act on this. The sixth term, therefore, will be A plus 5D minus third term will be A plus 2D equals 12. Now, the subtraction will affect everything in bracket. So this will become minus A minus 2D, which is 12. So here, A minus A will cancel out. So 5D minus 2D, that's 3D equals to 12. Therefore, D will be 4. Because if you divide both sides by 3, you obtain 4. Because it is only 4 you multiply by 3 to get 12. So I am going to put 4 for D into equation 1. So therefore, my 2A plus 5D, I'm replacing 4 with D now to be equals to 42. So 2A plus 20 equals to 42. So if I do, if 20, positive 20 comes here, it will become negative. So 42 minus 20 is 22. So leaving us with A to be equals to 11. Find A, common difference. Therefore, common difference D is what we obtained earlier to be 4. B, the first term, is A, which is 11. Then we have to find the 20th term. C20 will be A plus 19D. A is 11, D is 4. What's 19 times 4? That's 76. 11 plus 76 is 87. That's our final answer. So let's look at the second question. Second question says that the first, third, and the seventh term of an arithmetic progression, AP, forms three consecutive terms of a geometric progression. If the sum of the first two terms of the AP is 6, find its first term and common difference. So let's go. Now let the first term of the AP be A. Let it be A. And the common difference be D. Right? So it means that our first term is A. Then, because they said the sum of the first two terms, okay, the first, third, and seventh term, third is A plus 2D, and the seventh term is A plus 6D, right? We're told that since they form consecutive term of a GP, now, since I'm going to make a statement here that since these form the consecutive term of a GP, we are going to use a special property. Consecutive terms of a GP. We use the property. And what's that property? The property is that the square of the middle term right, is the product of the first and the third term. So, what is the middle term? A plus 2D. First term is A, and the last term is A plus 6D. That's the third term. So now, let's go. Now, when we say third term or first term, you know, we're given first, third, and seventh term, right? So that's one way to go. So if you expand this, square your A, that's A squared, then take 2D multiply A, that will be 2AD, then multiplied by 2, that will be 4AD, then 2D squared, so that will be 4D squared. Good. equals to, if you open this will be a squared plus 6ad. Now, this will cancel this. So move 4ad here, you have 2ad equals to 4d squared. See here, we cancel one of the d's here, right? So a, 2 can go in 4 2 times, so a will now be 2d. Call this equation 1. Now, recall that if the sum of the first two terms is 6, T1 plus T2 is 6. T1 is A, T2 is A plus D to be 6. And our A is 2D. So put 2D in place of A. 2D plus 2D plus D equals to 6. So 2D plus 2D plus D is 5D to be equals to 6. Therefore, D will be 6 divided by 5. Good, that's the common difference. So let's press on. Now, the other question says we should find the first term. So I'm going to put 6/5 for t into the first equation. So a is 2 times 6/5. So this will become 12/5. So our a is 12/5. So automatically now we found the first term. First term, which is a, is 12/5. And the second question is the common difference d, which is 6/5. I hope we have answered that question thoroughly. Good. So that is it. So let's proceed to the next question. Now, we were told that the terms are n combination 4. This symbol means combination, please. So n combination 5 and n combination 6. These are the terms of a linear sequence AP. So for any 3 terms of an AP, right, this formula will hold, right? For three terms of an AP, now this term will hold, this will hold. We can now say that the twice the middle term, similar to what we did for GP, is the sum of the first and the third term. So this becomes 2 times n combination 5. That's our middle term. Then the first term is n combination 4 then plus third term, n combination 6. Good. So now let's try to solve. Should I call this equation 1? Okay. Now, I want to use the combination and relationship that says that n combination r here is 5. 5 minus 1 is 4, right? Good. So for n combination 6, our n is still n, then 6 minus 1 is 5, right? So n minus r, our r here is 5 over then r plus 1, which is 5 plus 1, that is 6. Now let's put all the required equation into equation 1. If you put all the required equation into equation 1, now we know that equation 1 is double of the middle term. N combination 4 is still n combination 4. Remember, we are substituting into equation 1. Then plus n combination 6. We have found n combination 6 to be everything we have here. Right? Everything we have at this point. N combination 6 is still n combination 4. N minus 4. N minus 5. Everything over 30. Okay, it's now making sense. So now I have n combination 4 everywhere. So I will divide through by n combination 4. So if you divide through, so this becomes 2 into n minus 4 over 5. This will turn to 1. This n minus n combination 4 will go, so this will be n minus 4, n minus 5 over 30. Good. It's now making sense now. Now, to take out this fraction, I want to multiply all the terms by 30. So 30 times this now to remove so let's go. If you multiply 30 by 2, that will be 60. And 5 can go in 60 12 times into n minus 4. 30 times 1 is 30. And 30 will take out 30 there, n minus. So now, if I open this will be 12n minus 48. 30. So if you expand this bracket, this will be n squared minus 9n plus 20. So collecting like terms now, or moving everything to this side. So this will be n squared. If 12n crosses here, this will be minus 21n. Minus 48 cross here, that will be plus 48. So 48 plus 30, that's 78. Plus 20. What would that be? That would be 98. Good. So if you solve this quadratic equation n here, two numbers I will multiply to give me 98. And if I subtract or if I add, I will get 21. They are minus 14 and minus 7. Minus 14 and minus 7. So using the zero product rule, it means that n minus 14 is 0 or n minus 7 is 0. So n is either 14 or 7. So that's what we have to find, the value of n. Then, I think that is it. Right. So when we have to find the common difference, then we have to find the common difference. That's not hard. We know n now. So to find the common difference, b, now for common difference, we know that our terms now are, we're given n combination 4, n combination 5, n combination 6. Now, let's look at each of these combinations. N combination 4, where our n now is 7, right? So 7 combination 4. If you solve using the combination formula, n combination r, which is n factorial, n minus r factorial. This will be 7 factorial over 7 minus 4, that's 3 factorial, 4 factorial. If you reduce this will be 7 times 6 times 5 times 4 factorial over 4 factorial, 3 factorial. 4 factorial cancels 4 factorial. 3 factorial is same as 6, so it cancels. So this will be 35. So n combination 5, where our n is still 7. So using 7 factorial over 2 factorial, 5 factorial. This will be 7 times 6 times 5 factorial over 2 factorial, 5 factorial. That will cancel. 2 can go in 6 3 times. 7 times 3 is 21. Then n combination 6 is 7 factorial, 1 factorial, 6 factorial. This will be 7 times 6 factorial over 6 factorial. 6 cancels 6, so that is 7. So common difference, D is, we do 21 minus 35. Right? Or 7 minus 21. Either way you go, you will get negative 14. That is the value of the common difference. I hope that is taken. All right. So you have an activity here to do, the third and the sixth term of a geometric progression. And the other activity, the second, fourth, and the eighth term of an AP. That's the question over there. So, okay, in our next class, we'll start from trigonometric function. All right. So, this brings us to the end of our class for today. All right. So, you kindly go through the video, pause it at interval so that you can understand what have been done. Till our next class. Bye.